Hey, calculator. Here we go. Unit one. So here we go. Table one. You said second. This first table. All right. All right. Obviously, I'm going around it. You color yours in because I highlighted. You can see it. Table two. You said what? Y equals. Oh man. If there was a prize, Y equals almost like gold. Like it's like the gold medal. Yes. Oh yes. Oh no. All right. Here you go. That table. What you got?
The Link XT.
Link XT.
The
Where?
one under mode.
Mode. Where are you?
It's
Mode?
right next to second. Okay, that one.
This guy is at least silver medal because you're going to have to put in the letter X. Whenever you put in a function, that's the point of it. So with a highlighter, you're going to highlight those on your paper. That way you know where they are. Table four. What you got? Yeah. He's going to be important too. Like a lot, because again, to do all of the things where you need a situation, you need a graph, you need a table, you need an equation. As long as you get an equation in, the table is automatic. You're going to hit blue button table or second function table. That'll get you that. If you need a graph, you just hit graph. So two of these things, if you had a calculator, they're just straightforward. Last table, what's one that we use?
They just said graph.
Oh, they said graph. That's four. Okay, now it's free for all. Anybody else remember anything else we used on there?
Triangles, not
Equal won't take it. Caret and the square. Those two are important. This guy here and this guy here can help you do the same thing. Hey, this little upside down V. It's called caret. Now, I don't know how to spell it because I've never had to, but I know that's the name they give it. Someone who finds it out eventually can tell me. But
Could
for
you
now,
spell it caret?
it's possible. You can, yeah, however you want right now. The x squared, because oftentimes you're going to be using something to the second power, boom, he's there. The caret is, I need to take it to the third power, fourth power, fifth power, sixth power. It helps me get it up there. Again, today, next class, for sure, we want to get those calculators in your hand, but maybe not as much time today as next time. Any other ones that I want to say? All right, so let me say something like this. On your actual calculator, those top words up here are going to be in blue. Anything on this whole calculator that is in blue, you know you need to hit second function or the blue button. On this calculator, the letters A, B, C, J, K, L, O, W, the letters above the numbers, they will be in the color green. Anything you want to get to that's green on this calculator, there will be a green button, the alpha button. So some things are going to be intuitive. In other words, oh, that makes sense. To get the green stuff, hit the green button. To get the blue stuff, hit the blue button. So just be aware of that. But these here, pretty important. Let's hit clear. Clear is important. I type something and it's wrong, the wrong function. I need to get rid of this one. I go up to it and I hit clear. It gets rid of the whole thing. I'm going to mark the delete button even though we didn't use it that much. I just punched in one part of it that's wrong and I want to fix that thing. I have to arrow. Yeah, I'll arrow. Anything I'm marking you are highlighting? If I need to arrow left or right, obviously I hit the left or right, but if there's something I want to delete, just one thing, I arrow over it, and when I'm blinking, the cursor is blinking over it, then you know if you hit DEL, boom, it's gone. Yes, enter at the bottom is our equal. Hey, what's the answer equal? Boom, hit enter, like a computer. On, yeah, let's make on important, and off.
I thought that was just automated.
Usually we don't turn off the calculator because it can do it itself, but the off button, the off will be in blue. And so in blue, anything you want to get to in blue, obviously you'll hit blue button and get to off. Again, the calculator turns itself off, but for those who would like to preserve a little bit of the battery, you can hit the blue. What's another one that's important to me? Two more, or maybe three more. This, what looks like a minus sign at the bottom, is negative. In other words, in some of the problems, they'll say negative 3x plus something. Well, to get it to be negative, you need to hit that button. Some students have hit the minus sign. Minus 3x is whatever. And when you go to hit graph, the calculator will not respond. It's like, no, something's broken. You can't graph whatever you wrote, so you're going to have to find it out. Let's see, there's two more. Oh, these guys here. There'll be some times when you need to put something in a parenthesis. Open parenthesis, we call the left guy, he's above number 8. Close parenthesis, the guy to the right. Let me see if there are any others that are super important. Mode, not yet. Oh, I mean, we'll leave the alpha button. Anybody else for now? Trace, not yet. Table set, not yet. Windows, zoom, trace. No, not yet. Not yet. So let me pause and let you, under here, make a table for the domains and ranges, please. An XY table. Again, if you're not sure what that looks like, it's okay to go with somebody. So the multiple things are happening right now. We wrote down the domain. We wrote down the ranges. Make the XY table, even though, of course, some of you are already graphing because I should graph this out of order. But again, get it all there. We may see if we can think of a situation that goes with those numbers, or if we can create an equation. That part might be a little tricky for this one, so we may not even try and do that part. But for sure, I know you can make a table. For sure, I know you can graph it. For sure, I know you can get the domains and the ranges. And just in your real life, if you're around another math teacher, do not say domains and don't. The table is up there. Can anyone say whether this relationship or relation, they call it relation, not say relationship, if it's a function or no? Is it a function or no?
No.
I heard a couple of no's. Let me go back table. I felt like I heard one back there. Hey, back table, whoever said no. Why no? Yeah. I thought I heard a no over here. Right. All right, was there another no out there?
Yeah.
And why do you say no?
Because for a function, every x has one y. Whereas with this one, like the two x that are -2 turn into different y's. Does that make sense?
You are correct. Say it again. You think that might be it?
I would throw that.
All right, here it comes. Your table should be here. X, Y. 1, 2, 3, 4. You got a 0. I'm writing down my domain.
0, 2, -2, -4.
0.
4, -3, -2, -4.
I'll put my domains in blue. I mean, my ranges in blue.
Yes.
Please do me a favor. Write the word range above Y. One thing that happens in math class, they mention domain and range once, but they never keep stressing that domain goes with the X. Eventually, I'm going to start writing just the letter D and the letter R. And here we go. Squinting is fun. All right, here goes. We got a 2, 4. It's a -3. And is that a 4? Do me a favor. Put a star next to these guys.
But that's the negative.
Second, please. All the second guys, the -4.
I don't know.
The abbreviation for function is FCN. Go ahead and mark that, not function.
I don't know where it went.
Put in the dot 02. Where are you? 02, 02. I see you. Switching green. Where are you? -2, 4, -2, 4. Oh, by the way, these dots. Hey, who's graphing here?
Me.
I already got
No. Your word is graph. You can vote.
Oh.
I am graphing when I put these dots in. So for graph, you can always write to put a dot, place a dot.
Oh wait, are you trying to give my word away?
I'm offering it to all of us, but you're the boss.
No, you give his word away.
Yeah.
Give it to him.
We ran out of people, and then stuff in the back. All right, here comes 4-3. 4-3. Where are you? 4-3. 4-3. And where's the other guy who messed up? -2, -4. -2, -4. There is a problem there. This is for the second semester. There is a way to find out if you have a graph.
Thomas, I'm pretty sure that's wrong. It's -3 or -2.
Never mind.
And that one's okay?
That was okay.
I was anything you say.
For real.
How can you tell if something is a function if they give you a picture because we were about to ask it?
It's all in one line.
If you can draw a vertical line and hit 2 points on that same line, that you are finding a liar. He's double-faced, or double-faced, two-faced. You're so double-faced. No, it's a two-faced liar. Two-faced is like the Janus, what they named January after, is the god that looks to the past and to the future. But on a coin, you'll see two faces, one that way, one that way. They named January after that. But here's what you do. With your pen or pencil, when you look at a picture, and this is a picture, even though it's scattered dots, you try to find any two of those dots where if you can draw a dotted line going through it, where you can hit both lines with this vertical line. It's called a vertical line test. Please write that. Vertical line test. All right, we're going to get this. Let's see if we can do this 6 minutes. We've got to get some situations. Here we go. Question first one. This half of the room. Function or not function? All right. They say function. I hope they're right. This side of the room, this guy, function or not function? Okay. Okay, not function. I hope this side of the room is right. And it goes like this. Somebody may have been wondering, and I hope you were, should I be making the line right here, or like do I make it like right here? The rule is your goal is to try and find at least one place where it hits twice. So you got to go like, okay, well, it's not going to hit here, so that's not going to help. It's not going to hit twice here, that's not going to help. You're searching around for like, whereas over here, same idea. You're trying to find a place where it'll hit twice, so you win right here. But there is a student who could have thought, what if I put it right here on the edge? Won't it only hit one time? It'll be tangent to the circle. That tangent means you touch me only one time.
I just assumed you're supposed to put right in the middle.
Right. Your goal is to see if you can find where it hits twice. Your goal isn't to see, can I find a place where it only hits once? So if you find where it hits twice.
So if it hits the corner, technically it does hit once?
Yes. Here it technically only hits once. It's tangent to the egg. And to be tangent by definition means I only touch you one time. So when you hear, sine, cosine, tangent, that tangent has something to do with only hitting something once. All right, get ready for domain and range. Here it comes. Well, let's start with domain first.
So that's a function.
This guy here?
Yeah.
He is not. While he follows the
Well, because he
rules.
said it.
Right. Because he follows the rules, and if he was the only place you can draw that line, then yeah, you would have to say function. But you have the choice of putting it wherever you want. And if one of those places will hit it twice, then this guy, well, we don't even care about you. It's so like if you tell the truth sometimes, well, that's cool, but you're still a liar because most of the time you're lying. You know what I mean? You're lying. All right. Here we go. Highlighters. Do me a favor to determine the domain. I don't want this picture first for domain.
Wait, so we need to highlight?
Yeah, you're gonna need to. All right, we got domain and range. For each of the domain and ranges, you can't just have the numbers there. They have to be enclosed in something. Either have to be enclosed in parentheses or brackets. How do I say it? Open. I don't know how to say it, so I'm gonna just say it and see what you remember. The open circle goes with the parentheses. For the brackets, it's closed. Like, what does closed mean? Well, open is obvious. There's a dot somewhere that is open. Closed is just the fact that you don't see a dot anywhere. That is, this thing here is closed just by the mere fact there's no open hole there. So really, the only way you need to know, okay, when I use these, do I see any open circles? Okay, so let's see if I can ask first. For the -3 on the domain, is there an open circle? No, you don't see one, therefore, that must be on the left. If you gave me this domain and I had to draw a picture, I know I'd have to draw some picture where there's no hole all the way to the left. For the end of the domain, is there an open circle there? I hear a no, but
Yes, there is.
yeah, there is. This one floating up here, this one floating down there. And as a result, on that side, look at it, see if you're confused. Oh, how does he know to put that? Take a look at it.
Constitutes a closed circle and open circle.
If you see an open one, then it's an open circle. If you don't see one, then it's not there. What's the situation in real life? What does it mean? In the end, it just means that particular thing isn't included. Like up to when I make it all the way to the top of the when I make it all the way to the top, is there an open circle or not? I want to say closed, but if it's not one, it's the other. So I see an open circle or not. And decide what you're going to put. So put some down. Can you look at somebody else's after you try yours? Like, I don't know what. And if they put some down, the big deal with looking on someone else's is always like, hey, why did you put that? And then technically number 3 works. I put that because that's what number 3 says. And then you can say, oh, I get it. Or like, should there be some? Can you make an argument why you're using it? All right. Oh, shoot. All right, here we go. Here we go. This side of the room, what goes on the left side of the negative 2.3? Open, which means a parenthesis. This side of the room, 2.4?
Open.
Open. Yeah. Look at it, see if you get it. Now, if you don't get it, see what people say for this whole domain thing. All right. This side of the room, from left to right, where does the domain begin?
0.
All right. 0 would be here. I hear a negative 2. Negative 2 would beat 0, but there's actually something that beats negative 2 because of the arrows. And Anissa would be able to help us here.
Oh, infinite. Sorry.
She's like, what? I don't know this.
You can't
All right,
put it on the spot like that.
If there's an arrow, what it says is, unlike a dot, this picture stops. The arrow's like, the picture keeps going and going, they keep drawing it, but they're not. And this is math talk for, it goes all the way this way forever and ever. It goes to negative infinity, which isn't a number, but it's a direction. It's going to go that way forever and ever.
So infinity is infinity?
Yeah, I didn't want to say it already, but obviously this other arrow over here, if someone put down like 5.8 on a test, I almost want to give it to you because I know you know what's going on. But yeah, it goes to positive infinity. Here's the other thing: open circle or closed?
Open.
No, closed.
What?
It turns out with infinity, it has to be open. A point says it stops. Infinity, you wind up going that guy there, and there's this friend there. All right, this side of the room, range. Where does it begin? What's the lowest number, range? Negative 2, that's real. The other question is, where does it end? Top. Infinity, the arrows are going up. Unless there's a dot up there to stop it, there isn't. Closed and open. Ron says, how does he know the don't answer, but someone else. How does he know the bottom is closed? Someone else. It could still be a number here like we did, and be that. So that has something to do with it. But how does he know it's closed? Well, how do you know it's open? When it's open.
It keeps on going, but that one doesn't keep going.
Okay. I see you're going. In this case, the issue of whether it goes or not isn't the key. The key here is if it were open, it would look like this. You have to have a big circle to be open. If you don't see a big circle, then by definition you are closed. So in this guy, he gets to be that. Infinity, what's going to be on the other side of infinity? Yeah. Now, again, the idea is that you'll do more of these so that you get used to it. We got to look at, we're going to leave this page. Do me a favor really fast. Do the domain and range of that third picture down there on your own or with someone next to you. Highlight and write, choose open, close, but you got to compare it with somebody next to you. Either both you all need to be right or both you need to be wrong, but you all ultimately need to have the same answer. But try it for 30 seconds on your own before you check in with them.